So today we have a new toy. It's plastic. It's got wires coming off the sides. The ends of the wires have alligator clips, just like the wires in our castle kit. You can see those. It's got a handle. It's got a stationary handle that doesn't move. That's this part here. And then it's got a movable handle here. And if you look on the inside, there's some gears. As the first question is, what is this called? What does it do? This is called a Genecon. And then I just ask students, what do you think we could do with this to find out more about what it does? Well, students recommended that we hook it up to batteries, bulbs, and wires and see how it might be similar or different to a battery. If you open up the activity from today's post on Google Classroom, it's Unit 2, Activity 4, and it asks the question, how does a Genecon behave like a battery? So please take a moment and make the predictions down the left-hand side. How will the brightness of the bulbs from a 1-cell, 2-cell, and 3-cell battery pack compare? Why do they want us to do that? Well, to compare a Genecon to a battery, first we are going to have to establish some norms from a battery pack. So the first thing we're going to do is look and see how bright are bulbs with a 1-cell, 2-cell, and 3-cell battery pack. Do you think they'll get brighter, less bright, or all be equally bright? The second thing they'd like us to take a look at is magnitude of compass deflection. So we already know with a 3-cell battery pack we have about a 20-degree compass deflection. So with a 1-cell battery pack, will the compass deflection be more or less of the same as a 2 or 3-cell battery pack? And then lastly, how fast and what direction do you think we'll have to turn this handle to match a 1-cell, 2-cell, and 3-cell battery pack? Please pause the video at this time and make your predictions down the left-hand side. Once you've made your predictions, I'm going to encourage you to set up a chart into your observations with the number of cells, the relative, that's not better, the number of cells, the relative brightness of the bulbs, the compass deflection, and the Genecon handle speed. And we'll take a look at these as we go further in this experiment. Next up, we need to set our norms. So to do that, we'll just have to set up a standard loop. We've got a 3-cell battery pack. A standard loop is a 3-cell battery pack with 2 round bulbs and a loop. And I'm going to go ahead and hook the wires so that the bulbs light. Now, before we get rolling too far on this, I'm going to go ahead and set up my compass needle so that it's in the right spot for us to take compass deflections in a little bit. I have to look straight over the top of the arrow to get this in the right spot. And because I don't have an extra set of hands today, I'm going to use this tape measure to kind of hold it in place. Of course, you could tape it to the table. That's a more standard thing to do. So at this point, we're just going to check bulb brightness using the 3-cell battery pack first, and then we'll go through a 1-cell, 2-cell, and 3-cell battery pack. So hook it all up, make sure that we've got a closed loop, and now we're going to check out bulb brightness with a 1-cell battery pack. To do that, I can actually bypass and just make sure I've got wires on either side of the first cell. 1, 2, 3. Are the bulbs lit? Well, look really carefully. If I disconnect the wire, the bulb is not lit, but we've got just that little orange glow on the tip of each filament. So I guess we'd have to say yes, and that would be very dim. If we have a 2-cell battery pack, the bulbs are dimmer than they normally are, so we could just say dim. And then with a 3-cell battery pack, we're going to consider this bright, or standard brightness. I'll show you ways with bulb rates that we can show the relative brightness in addition to the words in just a little bit. What about the compass deflection though? As I ran that lab, my compass, or my wire, got pulled off my compass, so I'm going to have to reset that just a little bit. And we'll go ahead and pull the camera down so it's much closer focused on the compass. That's a little better. And that looks like it's about right. So let's go ahead and check Make sure the bulbs will light. All right, and then with a 1-cell battery pack, it looks like we have about an 8, now let's say a 10-degree compass deflection. With a 2-cell battery pack, we're at about 15 degrees clockwise compass deflection, and with the 3-cell battery pack, we're at just about 20-degree compass deflection. So, how do we turn the wires, or how do we turn the Genecon to match what's in the loop with the battery pack? So now I'm disconnecting the wires from the battery pack, and we're going to set this off on the side. And we're going to pull a Genecon in here. Here's the Genecon. And I'm going to go ahead and put this black wire on the green wire going to bulb 2, and the red wire going to the white wire that's heading towards bulb 1. And what should we do now?
I'm heading out.
Bye, Max. So if we turn the Genecon handle slowly, we can actually see the compass needle is moving. But look, if I turn the handle this way, the compass needle is actually going counterclockwise. Which way did it go when we did the lab just a moment ago? That way, the compass needle went clockwise. So maybe if I turn the handle the other way, the compass still needs to go the other way. So let's try to match bulb brightness for a 1-cell battery pack. So it was just barely lit, and that looks like it's close right about there. That's about a 1-cell. And we go a little faster, so medium speed to match 2 cells, and then 3 cells. And if we watch the compass deflection, can we match up with about 10 degrees, about 15 degrees, and about 20 degrees. So, taking a look on here to fill out the rest of the chart, we said with the 1 cell in the battery pack, we said the bulbs were very dim. Let's show with relative brightness, maybe we could just do 1 bulb ray. Where a 3-cell battery pack, it was standard brightness. So we'd say they were bright. And we'll use 3 bulb rays. So when we had a 2-cell battery pack, it was not as bright as the 3-cell battery pack in the loop, but it was definitely brighter than having a 1-cell battery pack. So we'll write dim, and we'll put in 2 bulb rays. Bright, dim, very dim. How about the compass deflection? So the compass deflection with a standard loop was about 20 degrees clockwise. With 2 cells, it was about 15 or 16 degrees clockwise. And with 1 cell in the battery pack, it was about 10 degrees clockwise. And then when we turned the Genecon handle, how did we use the Genecon? How fast did we turn the Genecon handle to match a 1-cell versus 2-cell versus 3-cell? We can just talk in very relative terms that we moved it slowly for a 1-cell to match a 1-cell battery pack, medium speed to do a 2-cell battery pack, and fast for a 3-cell battery pack. So that takes us back to our B question. How does a Genecon behave like a battery? Well, in what ways did the Genecon behave like a battery? Pause the video at this time and see if you can come up with 2 to 3 ways that the Genecon and the battery acted in a similar way. Write those terms down now. So perhaps you mentioned that the Genecon and the battery both lit the bulbs. That's great. So the Genecon and the battery both light bulbs. They also control how much charge is flowing, and we can see that in the brightness of the bulbs and the magnitude of compass deflection. Third, we now have seen by turning the Genecon in the opposite direction was very similar to when we flipped the battery pack way back in our very first activity. So the Genecon and the battery pack have the ability to determine the direction of charge flow. So those were the 3 ways that a battery pack and a Genecon are similar. They both lit bulbs, they determine the amount of charge flow, and they determine the direction of charge flow. How are they different though? Well, a battery pack is dramatically different because it could go pushing the charge and lighting the bulbs without me doing much. But the Genecon required me to put energy into the system, to apply a force and work to add energy to the system. So please make sure that you include one difference, one contrast in our answer to the question as well. That is, a battery pack has its own internal energy source, where a Genecon requires an external energy source, excuse me, and that would be from the person turning the handle. So those are 3 ways that a Genecon behaves like a battery, and 1 way that a Genecon and a battery are not the same. You can submit this activity once you have the chart filled out and the 3 similarities and 1 difference written out in sentences. There is not a reason to build a separate CER for this.